Here is the quadratic that they were talking about. I know because it's a positive x squared, it's a happy face. And they're wanting the lowest enrollment. So they're trying to find this y value. The y axis in this case is enrollment. So to find the y coordinate of the vertex, because that's a vertex, I use the x coordinate formula, which is this fella, to get 10.32. You then plug x is 10.32 into here, and just didn't have enough time. But if you evaluate that and round it off, that's the lowest enrollment that they were looking for. Now, if you were trying to do that on your calculator, the numbers are so small, I'm not sure you'd really get a very clear answer. And I'm not even sure that it's worth it doing that way. Although you could use Desmos. And
I used
Desmos would probably.
I used my calculator and then did the.
Yeah. So I'm suggesting that you use your calculator, but only in the sense that you use it to do the calculation, not to try and do it visually, because it's probably too difficult to read off a good, accurate answer. The numbers are so tiny that I don't think your calculator is up to the job graphically. But you can do it numerically, and it is up to the job in that case.
And that's 10.32 for the x?
Yeah, 10.32 for the x's. If you have enough time to fight your way through that, you can check it with me and see if it comes out. But double check that I actually did this bit right.
Equals, okay, minus.
Yeah, I did.
See, and here's the thing, going, because it said to do it with the calculator. And even like, I put in 44.3. I know I got 44.6 when I used the equation you just showed.
Okay, so okay. And the right answer for that question is, have you tried it yet to see if it works?
It says 44.6, but all of my guesses were like right within plus or minus. And it wasn't.
Yeah, I mean, you were close. I think it's just a matter of rounding off maybe that's causing the issue. Were you doing it as this calculation here, or were you doing it just trying to find this point by moving the little thing on your calculator?
I did it on the calculator because it said.
Right. I'm just adjusting it to as a calculation. So is this number here, you're saying this number here, this calculation here is 44.6. Is that what you said, Carla?
Yes.
Right. And is the correct answer 44.6 or 44.3?
Probably 0.6.
What does WebAssign say the correct answer?
It didn't give me a correct answer. That was the problem too, is it didn't give me what the correct answer was.
So you don't know what it is yet, right?
It does.
So
it
let
will
me see if I can find that. That little darling. 0.052. Oh, so my question is not yours. So that means I'm going to have to go in and look at the version that you've got. Okay, I can do that. Do score view. Right, Carla, last name Carla Flock. Gotcha. Right now, 22. I'll look at your responses. This is question 3. Click on 3. And the answer, correct answer is the 44.6 that I gave you. So the way I did it, What?
It just
I
seemed
think
like
the fact
I
they
was,
said solve using.
I was just thinking if I was in point 2 of the answer, but like it doesn't have a lot
You
of
were.
leeway.
Have you used? Yeah. Okay. Have you used up all your guesses?
Yeah.
Okay. Then let's see if we can fix that. Ah, shouldn't right. Okay, it's just been updated, so you got the points for it. So that was it. I think the fact that they said using a graphing calculator quite obviously made you think that you somehow had to graph it using it. They could have just said use your calculator. That might have made it more obvious that it was just a calculation. And you could have tried it in Desmos and might have got the answer that way as well. So what's that Shakespeare thing?
So
All's well that ends well. Right. Are we about everybody here? We are, handsome. Okay, well, good evening, everyone. I hope you've got some really good questions for me. If anybody want to start the ball rolling, well, we've already had one, which was a homework question from homework 22, number 3. Have we got something else you would like me to go over? No one has any? I'd like to see an example of this, or did you go over? I mean, I can certainly choose
find one right now.
Good, I got someone.
So in homework 20, I was going over square root. It's number 4. Square root negative x plus 8 equals x plus 8, and I followed the example like step by step, and I still got it wrong.
Okay, let's see if we can. I'm going to show you that thing, and you tell me if that's the one. Is that the question? Is that what you meant to say?
Yes.
Okay, so what you were going to do here, as long as you do it to both sides, it's okay, roll. So the first thing I'm going to do is square both sides. So when you square a square root, you get that. And when you square x plus 8, you have to realize what you're really doing is x plus 8 times x plus 8. A lot of people make the mistake that they think that the answer is just x squared plus 64.
Oh, you know what? I think I put negative. I put negative. So I don't know if it's negative or positive.
No, that's a different.
Okay, yeah.
Right, this guy here, if you square it, it's whatever is inside the square root untouched. It never changes. Yeah. Well, I got this. Might as well just finish it.
Okay.
Then. If you FOIL this out, you get, 8 squared, but that's 64. I'm going to add an x to both sides and subtract an 8 from both sides. So when you add an x, you get that, and you subtract an 8, you get that guy. Oh, that's a really weird calculation. Can I get it?
It might be minus 8. It might be negative 8 plus 8 squared equals 8 minus 8.
Okay, we'll start again. What goes inside the square root?
That negative 8 plus 8.
Okay, so that's the same. And what's it equal to?
X minus 8.
Okay, no, that's fine. If you square both sides, if you FOIL that, you will eventually get this guy.
This is what I have.
If you add, right, if you add
Oh,
an
that's what I
x to
messed
both
up at.
sides,
64.
you get that. And you take this guy away, you get 56.
I-
This factors
I see what I messed up at.
as a 7 and an 8. Okay. But for the benefit of those who are watching this then, there are two solutions. One of them is 7, the other is 8. And then I just check it out to see if one of them is no good. And the one that's no good is x equals 7. And the reason it's no good is when you go back to the original question, if you plug 7 in here, you get 1, and the square root of 1 is 1. If you put 7 in here, you get -1. They do not match. So that is I call them phantom solutions. They have, I can't remember what the book, their phrasing is, but this guy here isn't any good. It doesn't work. So there's only one solution, and that's x equals 8. And if I check that one out, they do match. If I try 7, you end up with the square root of 1 equals -1, and that's not correct. The square root of 1 is positive because there's no negative sign here, so it's positive.
Can you go back one
Another
second?
question? Sure. There is.
I'm just gonna finish writing it down. X 7.
Do we have, there we go. Is there any other specific questions or topics that you want me to go over? If not, we'll start looking at some topics that I'll just pick that I think might be useful. Last chance, are we good? Okay. Well, we call these things systems of equations. There are two methods that you can use for system of equations. One of them is called the addition method, and the other is called the substitution method. In this question here, what method would be the most natural one to use? Substitution method or addition method?
Substitution.
Right, and clue here. Single variable equals something to do with the other one. So in other words, the x can be replaced by that. That is a good example of a question that would use that. Well, in the substitution method, you replace the x with y plus 1, and you put it into this equation here. Distribute the 3. Oh, that one came out. Very nice. And you get y equals 3. This question is not finished until you know what the corresponding x value is. So that's really only half the solution. We know the y coordinate is 3, and we still need to figure out what the x coordinate is. So how can I use the fact that I know that y is 3 to get the x coordinate? What do I do now? I know that. How do I find x?
plug the 3 in for the y.
Mhm. Okay, so we put y equals 3 into this one. And there you go. Our solution is x is 4, y is 3. As a coordinate, I could write it like that. Right. So the quietness I was getting, was that just shyness, or you couldn't remember what method was what? You knew the two names, but you didn't know which one was called what. I'm trying to guess where the problem was. Is it just rustiness, shyness? Maybe you forgot that this was called the substitution method, so you weren't sure what to call it. Has anybody had any situations that they want me to go over in solving system of equations? Okay. Well, let's go for the worst case scenario. The most difficult system of equations to solve are ones that typically have a look like this, where there's x's and y's, but nothing matches. There isn't an easy way to change one of these, say, into a y equals, or for that matter, excuse me, an x equals. So the substitution method isn't going to work. So if you know the substitution method isn't really viable, then you go for the second method. It's called the addition method. Now in this case, we've got x's and y's in both equations, but we're nowhere near being able to add the two equations together. If I added them right now, all I would get is 8x and 9y, and that would be any benefit. So for the addition method to work, you want the same number of x's, but 1 plus and 1 minus, or you want the same number of y's, 1 plus and 1 minus. It doesn't matter which way you go, they both work. But you have to kind of commit to one or the other. Sometimes, just sometimes, it's easier to make the x's the same, plus and minus, or the y's the same. And if that's the case, that's great. This question, I don't think it matters. They're both equally ugly. So here's the first question. It's not much of a question, because either answer is correct. Do you want me to get rid of the x's, or do you want me to get rid of the y's?
X's.
Okay, let's commit. We're going to do the x's, these guys. So forget about what's happening here. Focus on 5x and 3x. I want them both to be the same amount of x's, and one of them's going to be plus, and the other is then going to be minus. So I need to know what to multiply equation 1 by, and in this case, what to multiply equation 2 by to make that happen. So what's 3x and 5x? What are they both going to turn into so we can make this happen?
15.
3x, 15. Now, to make this guy 15, you times them by 3. To make this guy 15, you times them by 5. But that will make both of them plus. So don't you have to decide to make one of them negative, right? Does it matter which one I make negative? No. So for no reason except I want to, the top one's going to get multiplied by -3. So -3 times that guy, -3 times that guy, and -3 times that guy. And the second one's just 5. So 5 times that guy, 5 times that guy, 5 times that guy. So here are our new two equations. But we can use the addition method on these two. If you add these together, they cancel each other out. If you add these two together, you get 29y. And if you add these two together, taking the chances, you got 85, take away 27. You are left with 58. And if you're really lucky, you can divide both sides by 29, and you've got one of your solutions. Y is equal to 2. Now, how am I going to get the other half of the solution, the x value? What do we do to find the x value?
Are we going to make the y's the same number?
Actually, you could do it that way, but that would be probably more work than you need. But that would eventually work if you did that. But you could do it this way, which is much quicker. Couldn't you replace y equals 2 in any one of these equations you like? So I'm picking the top one. So once you know one of the two, you normally can get the other one by simply just replacing it in an equation. So if I replace it into this equation, I have 5x plus 2 lots of 2 is 4. 5x, I'll subtract 4 from both sides. Oh. And the solution is x, y, 1, 2. So system of equations can be solved by this method here, called the substitution method, or this method here, called the addition method. One last, well, two things to do in this, and then I throw on to suggestions again. First thing is that sometimes you use these methods, the substitution method or the addition method, and strange things happen. Let's suppose I did the addition method. I got the two equations and they looked like that. And you add them together, you get 5x. You add them together, you get 20. And you get x equals 4, and everybody's happy. But sometimes the two equations look like that. And this happens. Both the variables disappear on you. Now, what does that tell us? In this case, 0 equals 20. What does that mean if that happens to you when you use this process? Is there a solution? if this happens, there is no solution. Means the system of equations is inconsistent, if you want the jargon phrase. There is no solution. So, can happen sometimes. And the other thing is that you sometimes get word stories. I've kind of abbreviated it, but the story would be, you know, somebody went into a place on Monday and they got 3 hamburgers and 2 fries and it cost them $19. And then the next day they go in and they get just 2 hamburgers and 2 fries and it costs them $14. How much does a hamburger and how much does it cost to buy a fries? Right, that kind of question. Now, when you have those questions, you have to turn them into a system of equations. So the first step is to figure out who you're going to call X and Y. And for this question, X is going to be the cost of 1 hamburger. And Y is going to be the cost of 1 fry. And so 3 hamburgers plus 2 fries equals 19. And 2 hamburgers and 2 fries equals 14. And from there, you solve the system of equations. Now, I'm not going to solve this one because we have a time thing, but we will talk about which method we could use. For this question, I call this equation 1, call this equation 2. Will I use the addition method or will I use the substitution method to solve this system of equations?
Addition.
Would you think it's easier to get rid of the X's or the Y's?
The Y's.
What would you get rid of? Right. Do you need to change everybody or could you get away with just changing one of them?
Just changing one.
And maybe change that one by just multiplying it by -1. So you could finish that yourself. But that's essentially the types of things that you get asked. Sometimes you just get an equation, a system of equations, and they say solve it. Sometimes you get a word story that then turns into equations and you solve that. Has someone got a homework question that they would like me to do that's not making sense or not working? Have they got a topic they'd like to do? That works too. You're all very subdued today. Okay. While you're thinking, I will tell you a joke, because I figure out if I tell you jokes, you will definitely ask me questions to stop me telling you other jokes. So if nothing else, this is going to get you to ask questions. What is the difference between an in-law and an outlaw? Well, you know how these jokes go. You're meant to ask, right? So what's the difference between an in-law and an outlaw?
What?
An outlaw is wanted. Carla, you got that
Perfect.
one. No, you like
All too
that
well.
one. Okay. Another one, in-laws. Mother-in-law, father-in-law, that kind of in-law, right? Two guys were in a pub in Scotland and they were drinking away, and one of them turns around to the other and says, "What are you going to buy your mother-in-law for Christmas?" And he looks at him and he gives him a skirl and he says, "I'm not going to buy her anything." And his friend says, "Oh, come on, you got to buy her something." He says, "No, I'm not going to buy her anything this year." And his friend said, "Why? Why are you not doing it?" So he looks at him and he says, "Look, she never bought the present I got her last year. She never used it." And his friend looks back at him and said, "Yeah, but it was a coffin."
What?
That was the joke. You bought her a coffin. She never used it. Oh God, that joke took ages to dawn. Get it? You bought her a coffin, she didn't use it. Too late now, joke's gone. It's poor little thing's dead. Sean, you like that joke? Yes. Have you got a topic or a subject that you'd like me to go over? Because asking for volunteers isn't working too well right now. Got nothing for
I
me?
have one.
Oh, good. What you got done?
The completing the square and then the resulting, I forget what they call it, the resulting trinomial.
Try to think about. Can you think of a question that does that? I know that they have a lot of solving quadratics using completing the square. I've seen those. Is it right at the beginning where they give you half a polynomial, half a quadratic, and you have to complete it into a full one? Is it like that?
Mm-hmm.
Oh, yeah. You have a question where you have something that looks like this. I'll just check that you can see what I'm doing. There we go. Right. So you have something like that, and they want you to complete the square on it. Is it that kind of question?
It is that, complete the square, and then I'm not sure what they want me to enter as the step 2, the resulting.
Okay, I think I got it.
They called it.
If you take this guy, completing the square is half the number of x's, right? Square it and subtract. So if you started with this, you'd have x plus 3 all squared and square it and subtract. I suspect that the bit they want is only this piece. So the resultant trinomial is that bit there. They don't want you even to bother about the -9, although technically it's there, they're not interested. So I believe that's what they're after. I can have a double check on that. Completing the square is homework 19. And if it's a question,
Yeah, I kept trying to put in the, you're right, they didn't care about the -9. They just wanted
this bit.
x plus 3. Right, for the
Right.
first.
So in the first box, there are 2 boxes. And what they want is they want like the x plus 3 squared in this box. And they want the x squared plus 6x plus 9, and they don't care about that in the other box. So if you're wondering which goes into which box, that piece, like just this piece, forget about him, goes here. And if you multiply that all out, that's what you get. So I'm looking at the answer, and that's what they were wanting. You want to check that on a question if you've got one in front of you, but I can see it here, it's going to work.
Yeah, I actually don't have it pulled up. I was just doing it from memory.
Okay, but can you trust me? That's what they want. I've got the answer in front of us. So if you take a note of that, when you have time, you can go back and fix it. Let's use that technique then. Suppose I had this guy, right? And I would like to solve x squared plus 6x equals 7. Suppose I wanted to solve that quadratic using completing the square. So what I would do is I'd half the number of x's, square it and subtract.
Mm.
So half the number of x's, 3, square it and subtract.
Mm. Mm.
And now what we have, if you add 9 to both sides, you have that. Well, let's see if we can take it to the end here. Right, got things all over the place. Okay, so solve this quadratic. I've taken this fella and completed the square, the complete bit, not just this bit, but the whole package, which is what typically you should do. Add 9 to both sides gets us to here. What am I going to do to both sides now to get closer to solving for x? I cover this up, it might help. What are we going to do to both sides to get closer to the answer? Not a lot of things happening here. I mean, I can certainly tell you.
X plus 3 on one side, and then 16, and then subtract. Or is that the wrong way? I don't
Okay,
know.
so let's see. Well, it sounds like you're on the right general track. If you take this guy here, right, x plus 3 squared, if you take the square root of both sides, you get an x plus 3. If you take the square root of both sides, your line looks something like that. Right? So I'm taking the square root of both sides. And what that gets me is plus or minus 4. And then we take plus version and the minus version, and we basically separate them out. And we're almost finished. Okay. If you look at x plus 3 equals 4, what should I do to both sides to find x?
Add 3.
On this side here, x plus 3, how would you do it?
Minus 3.
Or would you
minus 3,
subtract?
Great.
Minus 3.
Yes, subtract. And on
And
this
add-
side also
yeah.
subtract.
Subtract 3,
And
yeah.
so there's your two solutions. And what we've done there is we've solved this quadratic using the technique called completing the square. There are 3 main ways to solve a quadratic. You can factor. You can use this technique here called completing the square. And then the third one is to use the quadratic formula. Suppose I wanted to do one of the other techniques. For instance, suppose I wanted to solve that quadratic, and I was going to do it by the factor method. And what you would do is make sure that the whole thing is equal to 0, which it is here, and then you could factor it. We call these simple quadratics because you can basically just use the rule that two numbers multiplied together give me +6. And when you combine those two numbers, you get -5. And because of that, I know that they're both going to be negative. And then I just have to find combinations of 6 that work. So when I look at this guy, I'm saying, okay, how can you multiply two guys and get 6? When you combine them, you get 5. So what two factors would work in this question?
-3, -2.
Yeah. And then you take each factor and you find out what makes it 0. So in this case, x equals 3. So that's one of your solutions. And you take the other factor and you say, what value of x would make this 0? And the answer for this one would be x equals 2. And if you can factor them, they are really quite quick. Could you do this same question complete in the square, this method? You could, but do you notice how much more work it is? You know, so if you can, you should probably try to factor it first, because if it works, it's much easier. If it doesn't, well, you've got a backup plan. And the third technique is kind of your last resort. That's us using factoring. You can also solve equations, quadratic equations. Get my brain mixed up here. Using the quadratic formula. Right. In a quadratic formula, a is 1, b is the coefficient of x's, and c is 6. In the quadratic formula is this guy. And of the three techniques, the quadratic formula is the least algebraic, isn't it? Just a whole load of numbers that you have to calculate very carefully. The disadvantage is it's a really ugly formula, and so there's lots of opportunities to screw up. The simplest technique when it works is factoring, and I guess this guy over here is probably the middle, in my opinion. So easy, middle, ugly. Has anybody got another topic?
I have a question.
Yes, Vanessa.
If you have a quadratic equation, but it doesn't have a c, can you still, like, if it was just like 5 squared minus 5x,
Okay,
could you still use the quadratic formula?
You could, if you did, a would be 1 in this case, b would -3. What number do you think you have to do for c? Because it has to be a number, right? You can't just ignore it.
Would you have to use 0?
Yeah, and the quadratic formula would work. You can also use the quadratic formula for questions that don't have any x's.
That would
In
throw
this
me off.
case, a would be 3, b would be 0, and c would be -14.
Okay, I see that. Okay.
Now, The quadratic formula is a really ugly formula. So as long as you're careful about it, you will get an answer. You want me to just do that one just to show you the mechanism of what it would look like? So get that one to the line. I always calculate this piece first. It's called the discriminant. In this case, it's 0 squared. Take away 4 times 3 times -14. And I'm not going to try that in my head, that's for sure. And so I get positive 168. Okay. And so I go over here and I say, okay, x is negative b, which is negative nothing, so it's still nothing, plus or minus the square root of this guy, divided by 2 times 3, which is 6. So far, so good. Now, if you separate that out, 0 plus just gets you that guy over 6. And then if you 0 minus gets you that guy also over 6. So here are your two answers. They're not pretty, but they are the correct answer. Is there anything you think you should do to make this answer, and obviously that one as well, a little bit prettier? What I call style points. Can you think of a better version of a square root than 168? Can you think of two numbers that multiply together that give you 168, and one of them is a nice number, a square number like 4 or 9 or 16? $168. Can you think of any two numbers? One of them's a square, because there is one.
4 and 42.
So what you get is 2 square root of 42 over 6, which becomes a square root of 42 over 3. That's the best you're going to make that one. This one here is the same thing, but just with a minus in front of it. And that would be the end of that question. So you can use the quadratic formula for ugly numbers. Couldn't this be 1.234 and 0.006 or something, and the quadratic formula would still work? You just get really ugly answers, but that doesn't make it wrong. It just, that's what they are. Okay. On quadratics, how about this? There are two quadratics. There's random digits. Which one of them is a concave up? Which one of them looks like a happy face?
The top one?
Great. And the other one is concave down. Great. How can you tell? I know Rachel knows because she told me the right answer, but how do you tell? What makes this guaranteed to be concave up and make this guaranteed to be concave down?
The beginning variable is either positive or negative.
Right? And positive is a happy thing, right? And negative is a sad thing. You know, if you try to remember which way is which. Now, I've seen WebAssign questions where they give you this guy and they give you like 4 pictures and only one of them works. Which one of the 4 very badly drawn pictures, right, would be this guy? Only one of those 4 pictures is that top guy. Be a multiple choice question, so you either know it or you don't. It's not really involves too much work.
I would want to say D.
Okay. But what shape is that again? Is that concave
The
up?
top one or the bottom one?
Oh, the one with the circle, the top one.
Is
Which
it
one of
A?
these 4 pictures it could be? You tell me why, I'll agree with you. Why did you pick A?
I picked A because the y-intercept's 1 and then it's
That's it.
positive.
The number at the end is called the y-intercept, right? So see for a quadratic, if it finishes with +2, it'll cross the y-axis at 2. So she's quite right. Do you notice it crosses at 1? And secondly, like Rachel was saying, isn't this a happy face? So if I was trying to sketch this guy and I wanted to know which picture it was, I would be kind of like a process of elimination. I would go like, oh, it's a happy face. So it ain't you and it ain't you. And then I'd say, okay, I've got 2 happy faces. I wonder which one it is. One of the ways I could do it is, well, this one crosses at 1 and I'll make, let's say that's -1. One of these has a y-intercept of 1. The other has a y-intercept at -1. And you see the +1 here tells me it's that one. So kick that one out. Would you agree that guy is a concave up, a happy face quadratic? Agreed? Happy face quadratic. Let's find the vertex. Right, that guy. We did it right at the start of today. Isn't there a formula for getting the x coordinate of a vertex? Agreed? In this question, the A is 4, and the B is -8, and the C is 2. What is the formula for getting the x coordinate of a vertex?
X equals -b over 2a.
You remember doing that one right at the start? It was the formula I used with Carla, if you were here then. What this allows us to do then is for any quadratic, no matter how ugly these numbers are, the x coordinate of the vertex is always going to be the negative of b divided by 2a. The negative of that is 8, and 2 times 4 happens to also be 8. So the x coordinate is 1. To get the y coordinate then, you just replace the x with 1. And you now have 4, take away 8, add 2. In this case, -2. So the vertex would be at 1, -2. What is the y-intercept of this quadratic? We did that about 5 minutes ago. What
It's
number is
2.
the y-intercept? It's 2. So if you want its coordinates, it's 0. Is this shape a happy or a sad shape? Is it concave up, or is this quadratic concave down? Actually, I've just realized it's a daft question because I've just drawn the picture next door. Okay, so it's concave up. I could do a very, very basic sketch of what that quadratic looks like now. It has a y-intercept of 2. Has a vertex at 1, -2, and it's a happy face. Do you see how quick it was to draw a sketch of that quadratic using vertex, y-intercept, and the fact it's a happy face? Yeah, I think we'll give you a 5-minute break.